equation is a proportional equation, and sometimes in math we call it a direct variation, which you had some practice with last year. A direct variation is special because its y-intercept is 0, and that's what makes it think it's better than all the other equations. And because it has a y-intercept of 0, it makes it proportional. If you think of this example, back in the day when we were allowed to go to movie theaters, if you went to the counter and bought 5 tickets and each ticket cost $10, it would cost you $50. It's a proportional relationship. If you bought 8 tickets, it would cost you $80. But if you bought your tickets online, they charged an extra fee. That makes it not proportional because you're paying this extra fee. So if you bought 5 tickets and you had to pay an extra fee of $5, it would be $55. If you bought 8 tickets, it would cost you $85. It's not proportional. You can't divide by the number of tickets you got and get the same answer because of that extra amount. So when you see an equation where the b is 0, you know you have a proportional relationship. Direct variations are equations that are just y equals mx. Some books will say y equals ax, and some books will say y equals kx. They all mean exactly the same thing. M is slope, a would be the slope in this case, k would be the slope in this case. They're the same thing. In a direct variation, the slope also has a special name. Because these equations are so special, or they think they're so special because they have a y-intercept of 0, they also have a fancy name for their slope, and that is called the constant of variation. So if you ever hear someone say constant of variation, it means the same exact thing as slope. So we want you to be able to tell if you have a direct variation, aka proportional relationship, when you're looking at a graph. So you have to be able to tell if your graph is proportional. And for it to be proportional, there's only 2 things you have to make sure it is. It has to be a line, and it has to go through the origin. If it doesn't do both of these things, then it's not proportional. So this equation, this graph, goes through the origin, and it is a straight line. So this would be proportional. So this is a direct variation. It is proportional. This next example, it is a line, but it doesn't go through the origin. So it has an extra amount added to it. That would be our B number. So this is not proportional. Now you also need to be able to look at equations and decide if they're proportional. For an equation to be proportional, it must have an x and a y. It can't be a Hoy, it can't be a Vux, it has to have an x and a y. And it can't have any b number other than 0. So if you can rewrite the equation so that it's y equals mx, then it's proportional. This first equation, 6x minus 3y equals 12, has an extra amount. It has that 12. So this is not proportional. If you rewrote this, you would have a b number. Our next equation, if you rewrote this by sending over the negative 5x, you would have 2y equals 5x. That 0 doesn't matter. I'm going to divide by 2 to get y by itself. So I would have y equals 5 over 2x. It's a y equals mx, or a y equals ax, or a y equals kx. They all mean the same thing. This is proportional. Another way to check is to see if 0, 0 works in the equation. If you put 0 in for x and 0 in for y, this one would not work. If you put 0 in here for x, 0 in here for y, it would equal 0, because negative 5 times 0 would be 0, 2 times 0 would be 0, and if you add those together, you get 0. So 0, 0 must work. There can't be any extra numbers. Now from a table, this is where most of you had the most trouble when it came to linear equations, so we want to make sure you're getting this. There are two ways to do it from a table. One way is what we call cross products. If you do your butterfly and you get the same answer, so I'm going to do a butterfly here. 5 times 3 is 15. 1 times 10 is 10. This one's not proportional because I didn't get the same exact answer. The other way to do it is to write y over x for each ordered pair. If I write y over x here, I would get 1/5. Y over x here would be 3/10. They have to be equal to each other, and in this case, they're not equal. So this is not proportional. For my next table, if I do my butterflies, I'm going to get 8 and 8. If I write y over x, I would get 1 over 4. I would get 2 over 8. They are equal fractions. I would get 3 over 12 if I kept going. I would get 4 over 16. They all equal 1/4 if you reduce them. So this is proportional. And if you asked for the constant of variation, the constant of variation or the slope would be 1/4. And now for this special type of equation, we want you to be able to write these equations quickly when you see some data. So if you're given an x and a y and you're told that they do vary directly, they are a direct variation. That's just code for a direct variation or proportional. And we want to write the equation because it's proportional and the b is 0. Y over x will be your slope. You don't have to do any subtraction for slope here because one of the points is 0, 0. We know that these go through 0, 0. So if we put our y number on top of our x number, we'll have our slope or our constant of variation. So I'm going to put the y number on top, the x number on bottom, and that's our slope. So the equation here would be y equals -3/8 x. So these are easy equations to write because you don't have to subtract to get your slope. Because one point is 8, -3. We know 0, 0 works. So if I subtracted to get my slope, I would be doing -3 minus 0 for the top, y minus y. And I would be doing 8 minus 0 for the bottom, x minus x. And I would get -3 over 8. So now here, I know that this is a direct variation. So I'm going to write my y number on top, my x number on bottom. But that looks funky. You can't have a fraction and a fraction. So this literally says to take 1 and divide it by 1/2. When you divide by a fraction in math, it's the same as multiplying by the reciprocal. So the direct variation constant, the constant of variation would be 2. That's our slope. So the equation would be y equals 2x. So if you have a constant of variation, if you're told something varies directly, you're doing y over x for your slope and just writing your equation. Y equals mx. Have a good day.